Hi guys, it's Miss Kasparis where we left off last time. So, on this next slide right here, you should definitely try to do this on your own and catch me with an email or an inbox. See if you did not understand how to get it completed all the way through. But you definitely should be able to do that. This one you would end up being x minus 2, and x cannot equal negative 2. This one up here is going to end up being x cubed plus 2x squared minus 4x minus 8. So if you do not get those answers when you try it, email me and let's go through it. All right, this one has the same stuff, but it's also written, worked all the way out so you could get some reinforcement. This one right here talks about what we talked about before, removable discontinuity, where that would cancel out, and you'd end up with x not equal to negative 3, despite the fact that the simplified form has the domain all real numbers. Okay? You have to make sure you include that. All right, this is the purpose of this video for the most part, is the composition of functions. So far we've found an output for each function and then you perform an operation on it. In a composition of functions, you find a value from one function and substitute that value into another function to do something different. Just the next step. Let's find the composition of f and g. So it's f composition g of x using the tables. So right here, this is your problem. G of f of 4. So what you do first is you find f of 4, which gives you 1. Okay, so f of 4 equals 1. Take that 1 and put it in for g of x. So now you find g of 1, which is right here, which goes to 3. So g composition f of 4 is actually 3. It goes from 4 to 1, the 1 matches up, and then goes to 3. That would be how you took the composition on a table. All right? So f of g of 3 and g of f of 3. So here's your f function right here, and here's your g function. F of g of 3 we'll do first. G of 3 goes to 2. And we're going to take that 2 and match it up here on f. And 2 will go to 8. Here it is in symbols. G of 3, you get g of 3 equals 2. So f of 2 equals 8. Okay? So, that was our first one. We started here, and we ended here. The next one is g of f of 3. We'll start here at f of 3, which goes through to 3. Then, you take that 3 over to g, and it ends at 2. So g of f of 3, you've got f of 3 is 3. G of 3 then is 2. So g of f of 3 is 2. That's how compositions work. Okay? Can also be done graphically. Instead of a table, you've got a graph there. And they want you to find g of f of 1 and f of g of 1. So if we're looking for this first, here's f of x. There's your f. We want f of 1. Well, f of 1 is 2. So I take that 2 over here to g, and it is 0. Okay? So f of 1 is 2. Now find g of 2, what came out, and the y is 0. So g of f of 1 is 0. Okay. F of g of 1. So the first thing I have to do is find g of 1. That's the first thing. I find that g of 1 is 3. Okay. So I take that 3 over here. And 3 is at 6. That's the second step. So what you've got is that g of 1 goes to 3. Take that 3 and put it into f. And f of 3 comes out 6. So this is what you're doing. You're having the domain of f. You get takes it out to the range of f. Well, that range of f becomes the domain of g. Those are the same things. Okay? The range of f is the domain of g. And then you get the output of g, which is your range of g. All right, so lots of times it'll be strictly in symbols. F of x equals x squared and g of x equals x minus 3. Find f of g of x and g of f of x. Well, f of g of x means I'm going to take that whole g of x and put it in where x is. So f of x minus 3. And now, where you've got, whoops, over a highlighter. Where you've got x minus 3, you're going to put in for x. So, this is going to be x minus 3 squared. And when you multiply that out, you'll have x times x, which is x squared, x times negative 3, which is negative 3x. Negative 3 times x is negative 3x, and negative 3 times negative 3 is positive 9. So you get x squared minus 6x plus 9. G of f of x does exactly the same thing, except this time you're going to take the f of x, okay, this x squared, and you're going to put it in wherever you see an x in g. So we're going to have, that's going to be g of x squared. And when you substitute that in now, you get x squared minus 3. Because it's just a direct substitution right in there. So not too tough. This is actually showing a method 1 and method 2. This is when you take the x and put it in, and then get a value out, or get the value that you want to evaluate it for, and put that in. This is when you get a value first and evaluate it. That's negative 3 minus 5, which is negative 8. And then put it into g of negative 8, which will give you 64. Either one of these things works out just fine. If you've got a whole lot of things going on that you're going to have to do g composition f of a whole lot of different numbers, if you are going to have to do a lot of different numbers, then you would use this one. Get a function, and then you can just substitute each of those values in and make it work. But if you've only got one to do, then I probably would go with this, because it would just be faster. You would do the f of negative 3 first, just like we did before. And then when you got the negative 8 out, you'd put that into the g of x and get that. Method 2 is definitely faster if you've only got one to do. And that takes care of your compositions. We'll work on the modeling compositions. On the next video.